Hello everybody, welcome back to our first official topic, which is going to be examining firewalls and IPS technology. I really like this topic because I think it's important to always start with what are the terms. Of course we're going to get to the who, what, whens, and wheres, but we have to lay a common foundation, and that is again to go over terminology. So our very first term is going to be firewall technology. And I got to tell you, in my opinion, I feel like this term firewall has absolutely been marketed into oblivion. And what I mean by that is all these different vendors want to hop on the cool fad of, oh yeah, we've got a firewall, but understand what do they mean when they say firewall? Because again, they are broken up into a couple of different categories of a stateless packet filtering, and we're going to go over each of these in the next couple slides, a stateful packet filtering, and then the application layer firewalling. So getting into first our stateless packet filtering, this is definitely that one where in my opinion it's one of those marketecture terms, a term that has been taking advantage of the fad in the industry from a marketing perspective, but it most certainly, in my opinion, is not to be confused with actual firewalling. Folks, the key here is going to be stateless. So this could even be something as simple as your broadband router at the house that is simply identifying, if you will, an action, permit, a protocol, source and destination addresses and ports, and then even to some degree, very, very limited protocol state information, protocol session information. So let me pause just for one moment. Again, it's stateless, which means it does not maintain an actual table. Again, the dynamic nature of the applications are not monitored and tracked with this stateless packet filtering. However, on the flip side, you don't really need a lot of knowledge to be able to deploy this. There are so many scenarios where the default installation is going to be adequate just for stateless packet filtering. And then again, you're not able to go in and identify any kinds of discoveries on your networks, or as the slide here is saying, any kind of reconnaissance-based attacks. But once again, it is a fairly simple implementation. It is an affordable implementation or equipment to purchase and deploy. And it still does go over what we refer to as the 5-tuple, or if you will, protocol, source IP, source port, destination IP, and destination port. So again, without going into the details of the packet, the payload, the application, it's very, very high performance. And one more time, I'm not saying that we don't use these at all. This might be an approach that I would take on my perimeter router, where I want to do a very, very broad packet filtering and then let only what makes it past the perimeter router be further analyzed by my firewall, my actual stateful firewalls and IPS sensors coming up down the stream. So once again, as far as the stateless, it's going to be more focusing on that 5-tuple, as we mentioned a moment ago, not too deep into the actual application session, most certainly not into the data or the payload or into what the application is actually doing. So once again, a more simple approach to the configuration, more on a layer 3, layer 4, but one more time, because of its not going, the fact that it's not going so deep into the data field or into the application, that performance is going to be much, much higher. But again, in a scenario where you have, like today, many, many different kinds of dynamic applications, applications that have a whole bunch of different services, I think we will be better served by going deeper into the upper layers of the OSI model. Once again, layers 5, 6, and 7 of the OSI model. So that's where we get into, in my opinion, something that number one has been around for a very, very long time, and number two is not to be considered a firewall unless it is an actual stateful firewall. So as I started this whole topic, the term firewall has been thrown around haphazardly for quite a while, and in my opinion, it's not a firewall unless it's actually doing some kind of stateful packet filtering. So what's good about this is we still support all the old school tried and true, the 5-tuple of an access list for more broad filtering. We still have the ability with additional security options based upon routing information. Also support for network address translation, but I want to pause for a moment. I'm not saying your stateless packet filtering appliances of the last slide, of the last subject, does not support NAT. But again, our stateful firewalls support stateful inspection as well as these other features. And then also, once a session has been established, wait until we get into another topic coming up real soon. We're going to introduce a new technology known as FastPath. We'll say newer technology known as FastPath, where once the session has been approved by these access mechanisms, then it is written into a state table, and subsequent packets for that established session are going to be FastPath or processed more quickly. Notice also we have the ability, I'm going to keep this real simple. I'm going to keep all of these real simple and say we have the ability to simply go deeper into the packet, into the session for a greater degree of inspection. So validating the checksum. Look up of established sessions to see if this is a new session or a part of a flow that again has already been established. We're able to go deeper into the individual protocols, for example, with a TCP sequence check. Even not only, as we said a moment ago, but various types of translation options, but inspection on or into the translated session. And then one more time, folks, if for whatever reason the layer 3, layer 4 headers are off, we have the ability with our stateful packet filtering to adjust the layer 3, layer 4 headers. Now getting in even deeper, because if you remember a couple slides ago, we said the term firewall has become somewhat of a vague term, overly marketed term, but in that concept of a firewall, we have stateless packet filtering. We've already gone over that. We have our stateful packet filtering, and then we have, now we're going over the application layer packet filtering. So for me, the focus really is going to be on the word application, our ability to go even higher than the layer 3, layer 4 of what we just discussed, and then even into the layer 5, 6, and 7. So if I can, as I promised earlier, give you a quick customer story, we used application layer packet filtering for a client who had construction sites all over their county, and they were worried about access to equipment, access to the construction facility, what's going on at night when nobody's around. So we literally put up cameras with a Kyocera cellular router, and every time there was activity, they would FTP, those cameras would FTP images over the web to the customer's drive share or destination. It was a CIF share, to give a little bit more detail. Well, folks, right there, I don't know that I want just any old buddy FTPing over the internet, which is how these Kyocera routers were set up. So right there, we only allowed FTP from specific addresses, but that's nothing fancy. I also don't want, even if you're coming from permitted addresses, you to be able to FTP just any old thing. So we were able to, with application inspection, say you can only FTP these specific file types. But wait, there's more. We were also, if you think about those security cameras FTPing images of motion, all they need to do is an FTP put. They don't need to, or really a put or an M put, they don't need to be downloading anything over FTP. So my whole point in that quick story is with the application layer packet filtering, we were able to do the classics of you're only able to FTP from these addresses to this address. But then we can say even more, you're only able to FTP these specific files like JPEGs. You're only able to do this kind of FTP operation like an FTP put or an M put. So we were able to, once again with the application inspection, go even deeper into the packet and what is the application actually trying to do. But understand, I don't know how many times I said even deeper in that overview. The deeper you go, you're definitely going to have an impact on performance. So that's where, and we're going to be going over this in a topic coming up real soon, that's where we'll go over the portfolio, the Firepower portfolio, and the appropriate appliance, whether it's physical or virtual, that you would pick based upon the features and based upon the actual throughput. And also keep in mind, based upon what we're trying to analyze or we're trying to inspect, we have possibly some buffering limitations on the actual amount of data to be buffered and then analyzed. All right, as we said earlier, routing is a very, very big, very integral component in your firewalling technologies. So is it going to be our routing from a static perspective, that is the human, the administrator configuring a route as to if I want to go to this destination, I need to go through this interface and to this next hop? Or folks, are we going to support a host of different dynamic routing protocols. And by the way, let me pause. Number one, we have an entire topic on this coming up soon. So number two, I'm not going to say, oh, this is always the best, or this is always the best. I will say hands down, if I was asked, Isaac, what is the most that you've ever done? I would say a combination. So I don't mean to slip out of that question, but I have done many environments where we've only done static, many environments where we've only done dynamic, but the lion's share of my configuration has been a combination of both our static routes and our dynamic routing protocols. And then also, let's not forget, it's not just a matter of running routing protocols. Why are we actually doing our routing? As a matter of fact, I'm going to try my best. We'll see how everything works out. I'm going to try my best to always start a subject with why. Why do you care? Why are you listening to me? Well, guys, why are we actually doing our routing? Is it going to be to learn all possible paths, in which case you will be doing a dynamic routing protocol? Or is it going to be to configure, to define all possible paths, in which case, again, you'll be doing your static routing mechanisms, your routing entries. And then also, last but not least, from that routing knowledge, we got to pick the best path to our destination. So again, I'm going to generalize this a little bit more, having knowledge of all paths, and then again, picking the best path as the slide is mentioning here. So guys, once again, as far as the routing protocol comparisons, please note the difference between this slide and the last slide. The last slide was, how do we come up with our routing knowledge? So that's why technologies, under technologies, static was one of our entries. Now we're simply going over the actual protocols. So whether it's the RIP, Router Information Protocol, an interior gateway protocol that is only running within your organization under one administrative body. But again, guys, be careful. This is kind of an interesting point that I remember when I read this, I thought, wow, that's an interesting point. RIP is the most deployed routing protocol, but again, that does not mean it's deployed in the largest of environments. There's a difference there. It is the most deployed routing protocols because it's ideal for smaller environments, smaller, I would even say medium, small. I don't know if I would say medium. I would say small, medium, small environments. And if you pause for a moment and think about it, we have a lot more small to medium, small environments than we do Fortune 100 environments. Unfortunately, it's depending upon the version of RIP, whether it's again going to be RIP version 1 or RIP version 2, it's going to determine how the routing protocol does its updates. While, excuse me for a moment, we come over here to OSPF, Open Shortest Path First, and we see it's designed for larger size environments, even to enterprise environments. But I want to be clear, still within the organization. While again, OSPF uses multicast updates. And excuse me for a moment, I'm going to kind of bring us over, now that we've gone a little bit down, I want to bring us over to the Border Gateway Protocol, or BGP, slowly building the slide and making comparisons after we've laid the foundation. Border Gateway Protocol is an exterior gateway protocol. It's in a different category altogether. As a matter of fact, it's the only protocol, kind of lonely, but the only protocol in the EGP category. And if I may be a little bit more technical, a little bit more nerdy, it's actually multi-protocol BGP. But again, in a routing class, we can go over what those details mean. But please understand, very large to enterprise. When they say TCP connections, number one in BGP, everything is so very manual, and that's a good thing. You have to manually define, for example, this is my neighbor, these are my neighbor attributes. And one of the big reasons is because routers establish TCP connections with their neighbors. And then again, this update is coming from this neighbor, this update has this attribute or that attribute, is a very strong validated mechanism for the various updates. And guys, when we say complex set of metrics, this is again back to picking the best route, if you will. Again, I'm not going to go over it here because this is meant to be a security firewall topic, but I'm telling you now, I teach the routing classes, and BGP has a 13-step pick the best route process. So when we say complex set of metrics, they're absolutely being very serious there. Anyways, let me back up. Like I said, I want to lay the foundation and I want to compare and contrast all these. This complex set of metrics compared to over here, RIP is pretty wimpy. It picks the best route based upon the shortest hop count, and a hop count being through a router, a passage through a router. And folks, please understand that I could go through this router, to my destination over a wimpy little T1 link, or I can go through these two routers over here through two 10 gig links. RIP would actually prefer the one router, the one hop count path over that wimpy T1. And then again, finishing up here, comparing that to OSPF. OSPF has a little bit more knowledge, a little bit more information that it can maintain about the individual interfaces, the links, and the total paths to the destination. It actually has the ability to calculate a cost, but that cost is going to be based upon the bandwidth. So many different options, so much information. The good thing is, if I back up just one more slide, our firewalls support these different routing mechanisms, so you can have a talk with the people on your team and pick which routing protocol is going to be best for you and your environment. All right, now we're getting into the IPS technology, or intrusion prevention system. Folks, these are physical appliances, maybe even integrated into their own appliance, or even integrated into the same appliance that is doing firewalling and intrusion prevention. The big deal here is intrusion prevention is going to be in line with the actual communication. So give me some time. We're going to go over again in another topic how, because this appliance is in line with the traffic flow, we have to be concerned about any kinds of failures on connected interfaces or even failures on the appliance itself. But what's so nice is that all traffic has to go through it. It is in line, meaning we have the ability to go even deeper in our inspection, the behavior of the traffic, even down to the application, all again because it is deployed in line. But at the same time, we have to be concerned about performance and picking the best appliance for our throughput needs. Again, real quick story, I had a client that they had a 10 gig connection between their branch locations, and they actually wanted to perform 10 gig of inspection. And I told them right there, not only 10 gigs of IPS, but also 10 gigs of firewalling. And I mentioned to them that, yeah, it's possible, but the appliance that you're going to end up using, if you want that true line rate, is going to be on the higher end of the portfolio. Now, backing up here, again, the beautiful thing about IPS allowing for deep packet inspection is we can even go through and reassemble the protocols and the sessions. Just in case an attack has been spread across multiple different packets in a session, we have the ability to do a reassembly and then analysis. State tracking of the session, very similar to what the firewall is doing. And as we mentioned, once again, the ability to not only reassemble the individual packets, but also build the session. So look at all the communication from a bigger picture to identify if maybe the attack is not obvious inside of one packet, but these packets across the session, they do constitute the attack. And then also very, very nice is our ability to go even deeper into the application. So for example, not just identifying, especially these days, very, very important, that this is TCP 443, again, HTTPS, but even the ability to say, hey, this is Facebook, and they're trying to do Facebook chat. So our ability to go even deeper into the application, especially because in this technology, in the old days, a lot of the more complex emerging applications were able to evade the IPS, the original IPS technology. Now, speaking of the new days, speaking of the next generation, please understand that those last few slides were all going over the basics of firewalling and basics of IPS. Now where we are, especially with the firepower portfolio, is we're in the next generation firewall, next generation intrusion prevention. So what does that allow? Anomaly detection. Hey, this protocol, this application, this session is not behaving properly against this signature, against this definition. Also, any kinds of modeling, that is the engineers, the super intelligent people over at Cisco's Talos, they're able to come up with modeling of how do protocols and applications work, and that information is downloaded to your appliance so you can look at you can analyze the traffic to see if it's behaving according to that model. Also alerting, because let me pause for one moment, especially with this thing being in line, you might want to start off with more of a discovery and just be notified of any kind of suspicious behavior. while maybe a little bit later you can switch over to actual blocking on that suspicious behavior. Of course, able to analyze the traffic, especially these days, malware detection. Our features, some advanced features that we're going to be talking about coming up a little bit later with our security intelligence and application filtering, actually give us some time. One of the topics coming up later is a flow chart of what events, what features take place in the flow of the packet. We're able to do our URL filtering. Folks even go deeper and say, I want to authenticate the user, and based upon the authenticated session, the user session, allow or not allow or block their traffic. Of course, we have support for our dynamic routing protocols, network address translation. Let me pause for a moment. Not just support for these mechanisms, but also the ability to correlate what's happening when these additional features are being used. So what do I mean? Well, again, it might be an attack that is unknown because the translated address is unknown to the appliance. Or with this ability, with this capability, we can see, this address had an alert, this address had an alert, and because I am in line and I have knowledge of your network, I know that this address and this address are the same session, they're the same flow. It's just this address is the pre-natted outside address, this address is the post-natted inside. Again, it's the same server this attacker is trying to get to. And again, I have that knowledge because I have mapped out your network and I'm able to trigger an event letting you know of a pending attack. Really nice options, especially with the additional knowledge of your network. So thank you again for listening. This was simply a review of the basics of your firewall technologies, everything from the overly marketed, in my opinion, stateless packet filtering, like a simple router with simple access list, into a true firewall, again, in my opinion, a stateful packet filtering, and then also application intelligence going even deeper into the application, and then finishing up with our next generation firewall and next generation IPS available to you from the Cisco Firepower portfolio. Thanks again for watching.